So open your notes to the page that says exponential growth. This is an A-B review. You did this in A-B. We're just going to take it a step farther. Actually, I think the problem I give as an example was on your homework last year. So anyway, with exponential growth, the way you kind of know you have one is when it says that the rate of change of some quantity, usually that's, like I said, like a population or some living quantity, sometimes money. I don't know why my pen won't write. There we go, I got it. Anyway, when it says it's directly proportional to the amount present. So that's an indicator that you've got exponential growth, those words directly proportional to. And rate of change in our class is a derivative. So they give some examples on here, like saying the more money you have, the faster it'll grow. Well, that's totally true, right? And it says the more you scratch an insect bite, the worse it'll get. The more addicted someone is to a substance, the more the addiction will grow. These are all rates of change that are directly proportional to what's happening at a given time. So when we write that rate of change, we say the rate of change with respect to time, and it's usually not dy. Usually we use something that, like if it's bacteria, we'll use dB. If it's some sort of a radioactive element, we'll use like maybe R for radium or so, you know what I mean? Give it something where it means something to you. From last year, maybe you remember how this played out, but we say it's directly proportional, so we have what we call a constant of proportionality, and universally that is K. All right, so K is universally accepted as a constant of proportionality, and it's directly proportional to the amount present. The more I have, the more it's going to grow, like money. So it's Ky. Do you guys remember without looking, when I solve that, what I get? Sect. Yeah, but because we're going to be taking this into another realm, like we're going to tweak it a little bit, the process is really important. So what we really need to do is solve this for y one time, and then we'll assume we know that. So when I want to solve this for y, I need to separate. So we do 1 over y. We'll do this once, and then only do it on the ones where they tweak it, where it's like not directly proportional to the amount present, but they might say it's directly proportional to the difference of it and something. Then you have to go through this process. But for just direct proportionality, let's go solve that. We'd say 1 over y dy is equal to k dt. So we're using separation of variables to come up with a model here. So let's go integrate both sides. The antiderivative of 1 over y is ln, absolute value of y. Usually this is population and stuff, so it's rarely negative. So you can actually pretty much always, it is never negative. So you can chuck those absolute values anytime you feel like it without having a mathematical reason to do so. On the right-hand side, what's the antiderivative of k with respect to t? kt plus c. So we have this constant here that's going to come around. And when we do our exponentiating like this, then we just get y is equal to, and we've done this so many times, it's e to the kt times e to the c, so we make that its own constant out front, and we write it like this. And that does always work. It's y equals sect, and it is good to memorize it. I prefer, though, for the word problems, that instead of calling this c, it's actually the amount present when t is 0, because when t is 0, e to the 0 is 1. So call it whatever your original population is sub 0. I think that will help you more than calling it c. So if we're dealing with radium and the amount present at the time of some explosion in the atmosphere is whatever, call it R sub 0. That helps, because if you call them all C, you tend to get kind of goofed up. So it does say that is worth memorizing and to know it backwards and forwards. Also know if they tweak it, that you just have to run through that process. So this is one we did last year, a very basic level, and it's bacteria growing in a lab culture, and it says the instantaneous rate of change, that implies a derivative, and it's bacteria growing over time. So when it says write the Diffie Q, that just means dB dt. That's the rate of change, and they always look the same for your differential equation. It's directly proportional, so you write k times what? To the amount present, kb. It's always k times whatever you're calling your dependent variable. All right, so that's the differential equation. When you're doing your homework, if it just says set up a diffEq or a differential equation, you're done. Then it says solve it. No need to solve it, just have it memorized. My answer would be B is equal to B sub 0 e to the kt. That's what's going to happen for that one. Now, we're going to take some shortcuts this year that we didn't take last year, and we'll get to those because the same thing actually happens every time you go solve for k. There's actually k is a formula in and of itself, so we'll talk about that. We'll do it the long way though once here. So it says suppose initially that there were 5 million. That point is being given to you so that you can find b sub 0, also known as the c in the sect one, right? So then they have to tell you what's happening later. Why do they have to tell you that? 1 point you need so you can get this. What do you need another second point for? So you can get which variable? K, exactly. So they'll tell you what happens later on. If they don't, they have to tell you the growth factor. Like they'll have to say it's tripling or doubling or has a half-life. Okay, if they don't directly tell you that. Now what, yep, what did I do? 3 hours. Oh, 3 hours, thank you. All right, so let's solve this for k and then talk about kind of the algorithm for it. So when I go back up here, b becomes, when I put in a 0 for t, this is just b sub 0. So I have 5e to the kt, correct? So the first point they give me is the start. It can go right in. The second point they give me is so I can figure out what k is. But k is really the same thing every time. Not the same number, but the same appearance. So watch when I do that. What this is saying is that 3 hours later, so I'd have 5e to the 3k, it grew to 7. What you do at this point is the same every single time, and you get kind of the same result every single time. So if you were solving this for k, what would you do? What would you do? Divide by 5, because that's the growth factor. It grew by 7 divided by 5. If this went from 5 to 10, you'd say the growth factor is 2. It's doubling, right? If it went to 15, you'd say it's 3. It's tripling. The growth factor here is 7/5. It's this over this, and that will always end up over here on the left. I'm going to run into this because I don't really care about the graph. It's exponential growth there. Done. Anyway, where was I? And you're always going to do the same thing at the next step, right? What's this next step? ln. So it's always going to be ln of the growth factor, and it'll save you some time, especially multiple choice. If you really get why it's the same every time, don't do it every time. So that's really ln 7/5, right, equaling 3k. What do I divide by every time? This one, 3, but in any other problem, it's going to be the same pattern. What will be on the bottom of your fraction? The time that it took for it to grow that much. So kind of look at what you're always going to, this would be over 3 is equal to k. Then what I suggest you do is store that on your calculator. So go to your calculator, then you can just draw it up, store it in k. So go ln 7 divided by 5, make sure you close the parentheses, divide it by 3, hit your store button, and then hit alpha k. And then you can just draw it up for every problem after it. Some on your worksheet have like 3 or 4 more questions, and you don't want to round k because then you're off, right? And you also don't want to keep typing it. So just go store it. Are we all stored? And it's ready to go? So we'll put that on the next page of your notes in just a minute, or maybe at the top of this one. But let's go answer this question. So now that K is stored, it says, what will the bacteria population be in 1 full day? Well, this is in 3 hours. 1 full day is 24-hour time period, right? So the amount present at any given time is the amount I started with times E to the K that I already had stored times the time, which is 24. So then go ahead and do that, and you can just draw it up under K. So do 5e to the alpha k times 25 or 24k. So store it and then use it. It makes it so much easier, and then your answers don't need to be rounded at all, and they'll be identical to that's how I made the key. So if you do it this way, your answers will match mine to the 1,000th. All right, what is it? 73 point what? 789, and this is in millions, so that would be million. Can someone back that just because I'm not, we're good? So then it also, there's questions that will ask you, well, how long will this take? This is actually a pretty important question real worldwide. Like, how long will it take so that enough of the radium has diffused so that we can actually let people go back there? You know what I mean? So the time question's pretty big. Like, when would this disease be eradicated? How long would it take if we're able to get the disease to shrink, shrink, shrink until less than one person has it? That's good to know, right? So when you're solving for time, it is also very algorithmic. So watch, because I never gave you shortcuts for this last year because it was a new skill and it was good to crank it out all the time. And keep in mind, in this class, I have the top 20 people from last year, but many people need to run through that algorithm a lot. You know what I mean? So let's go take a look at this. When will the population reach 1 billion? All right, so that's giving me the B. Because remember, I have B equals 5e to the kt. I'm in search of t. But this is in millions. A billion is how many millions? 1,000. Yeah, so I'm wanting to get 1,000 millions, because that's what the problem is given, and that'd be 5e to my stored k times t. So just then you don't have to keep rewriting it, you don't have to keep re-entering it. What always happens here is you end up dividing these, and you'll get 200, right, is equal to e to the kt, and then I'd go, what would you do next? I'd ln that, right, and then what would I do? Divide by K, which is stored. And then you can kind of shorten up your work if you really get what's going on. Can you guys go tell me when will the population reach 1 billion bacteria? Maybe that's when we've got a huge issue. You know what I mean? Maybe that's when outbreak starts. I don't know. But this is actually a skill used quite a bit. I don't know what the answer is because I haven't done it. 47.24, and this is in hours. Okay? That's kind of what they do when they take a strep test. You know how you have to wait a half an hour after they swab your throat with a big Q-tip? What are they waiting for? The bacteria to grow enough so they can see whether it's streptococcus or not. So there's a time period that somebody has determined. This is how long it takes if it is strep. If they don't see it after a half an hour, what do? They tell you you don't got it. You know what I mean? It's a good skill. So let's go take a look at this one and see if we can do this kind of a little bit shorter. This is an actual AP question. The answer is C. Let's go take a look at what we've got here. During a certain epidemic, number of people infected at any time increases at a rate, there's my D people DT, that is directly proportional to the amount of people that are infected. The more people that are infected, the faster it's going to spread. All right? I immediately go from there to solving it. So I'd write P is equal to what? P sub 0, e to the kt. All right, I would then go take a look and see what they're giving me. 1,000 at first discovered, so they're giving me 0, 1,000, right? And then 7 days later, 1,200. Now keep in mind, and if you want to go plug those in, go ahead. Let's go put the 1,000 in anyway. I've got 1,000 for my start, e to the kt. But remember that k, I told you it's always the natural log of the growth factor divided by the time it took to grow. We'll write that on the top of your sheet in just a second. But what's the growth factor? Just divide these. The growth factor on this one is what? Give me a fraction for the growth factor. It's 6/5. Exactly. If it was doubling, it would be 2. If it was tripling, it'd be 3. If it was half-life, you put in a half. This has a growth factor of 6/5. K is always the natural log of the growth factor divided by the amount of time it took it to grow. So what's going on the bottom of my fraction? 7. If you're dying to plug this in, I mean, it's going to work out the same way anyway. If you're somebody who's like, I just don't know if I'll remember that, I'm just not sure I quite get that, then you'll manually just put the 12,000 in. You'll go put this 7 in for time. You'll divide, you'll ln, you'll divide by 7, you'll have k. So that, but it's kind of algorithmic, so you might want to store that in your head for speed purposes, because a lot of times on the AP exam, they ask you just for k, and then you don't have to show any work. You can just go, okay, what's the growth factor? They told me it was a half-life, so ln a half divided by however long it took it to cut in half. Can somebody give me It must have worked out, right? That's the ln, that's the k. Go store that in k. So let's write store that in k, and then go back right here and plug it in. Okay, so what was the question? How many people are infected 12 days after? So put your stored k in and a 12. Go work your calculator. The quicker you can work it, the better. It'd be 1,000 e to the stored k times 12. And you should get 1,367. Did anyone run it through their calculator yet? I'm just making sure I starred the correct one because sometimes I don't. All right, so we're good to go. On the top of this sheet, what I want you to write, do you have some room up on the top? Okay, write this. Let me move my page down a little bit. On the top of the screen, a couple things. If they tell you the growth factor, then they do not need to tell you what it started at because it doesn't matter. So if they tell you the population is tripling, really it doesn't matter what p sub 0 is because it's going to triple. So you really can just set 3 equal to e to the kt. Does that make sense? So if they tell you it's doubling, don't come and say, but they didn't tell me the start. They won't. If they're telling you the growth factor, you don't need to know the start. Fair enough? So if they tell you it's half-life, that maybe some medication you take, I actually take Ambien for sleep reasons due to the chemotherapy I went through, and it has a very short half-life. So that when I had a surgery last year and they asked me, did you take any medication in the last 24 hours? I was like, oh crap, I took that Ambien. Are you serious? So, and you have to tell them because if it's an issue. So I said, well, yeah, I took Ambien last night. And they said, oh, that's only got a 4-hour half-life, so you're good. You know what I mean? So every medication you take, pot has a super long half-life. So you could smoke pot today, and there's enough in your system in 2 weeks for them to know you smoked pot. I mean, it does. It has a very long half-life. Radioactive stuff like Chernobyl, I don't even think you can still go there because it's taking so long for that to be cut in half. So most things that are radioactive have long half-lives. Medications that you take, most are short. Like if you take cough syrup, it makes you sleepy, or you know what I mean, or like Benadryl. But when you wake up in the morning, you're usually fine. It's that half-life kicks in. So if they tell you something has a half-life of, say, 9 years, what's your K? Without any work. ln, 1/2 divided by 9. So we're going to write a little note over here that k is always equal to the natural log of the growth factor, either explicitly given as tripling, doubling, halving, or found by, like we did, saying, all right, it is this over this. All right, so it's ln the growth factor over the time it took it to grow that much. That's a nice, slick, easy, fast way to suck out a k out of the problem. Do you get that? Are we okay with that? All right, you guys are so smart, I'm sure you. All right, so on the next page, go do this one and get that really quickly without any work. You shouldn't need to give me work. Honestly, it's a calculator entry if you just understood the last 3 minutes of what I said. And again, this one's only asking you K. And sometimes on the AP exam, that is what it's quicker to find K. And if you can find K, you can do the whole problem. So go ahead and pop up a hand when you've got it. It should be that fast, Landon, right? Because what's the growth factor? 2. It's ln 2, and how long did it take to double? 10. It's ln 2 over 10. It really is. That's not how it's expected to be done. You're expected to say, okay, it started at p sub 0, and then it doubled, and then it's e to the kt, and then these cancel. But you end up doing, you know, putting a 10, that's what you do. So why do it all the time? I threw in a wackadoo right in the middle for muscle memory. So go do the one in the middle just to throw a push-up into the middle of you doing a bunch of sit-ups. Has nothing to do with exponential growth. Actually, let's just do it together so I can get you your packet. Let's go have at it. This one is saying find the value of y, correct? What do I do first of all? Yeah, separate, but there's really nothing to separate because they're giving me it all in terms of x. So this is really just going to be the integral of sine x cosine squared x dx. Really, I mean, that's what, when I integrate dy, I get y. So there, that's really what I'm doing. Is this a by parts or not? This is an easy what? Who you? Cosine. Exactly. So let's do that. We should be able to do that in our head. This is u squared. What's du? Negative. So I've got a negative fraction correction, and I'm ready to go. That would be negative u cubed over 3, right? Plus Carl. So that's a negative. I'm going to go back to u. Who was u again? Cosine. So that's cosine cubed x over 3 plus Carl. How do I get Carl? I'm just throwing a weirdo in here, Emma. How do I get Carl? Yeah, it's got to be 0 when I do cosine pi over 2. What is the cosine of pi over 2? 0. So Carl's 0. So there's my function. And I'm supposed to figure out, what does it say? When x is 0. Well, that's easy. What's cosine 0? 1. That's negative 1/3 for B, and we're done. All right, so the last question, again, is off of a multiple choice. It's an old one. It's off of 98, but it's such a no-brainer because what's the only one in the sect format? There's no work to show. They just want to know that you know. You know what I mean? So B is it. All right, so when I give you, I'm going to stop this. Does the next page say logistics? Yes.